Hello viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about some overlooked topics like NASA's crawler transporter. So let's dive deep into it. So here's the deal, why the heck you needed this puppy? Well, reality is, imagine a world where you are building the biggest rocket, successful rocket, and you have to make it vertically. As in, the size of this skyscraper is so huge, it's not practical to go yoink. So fundamentally, you have to build it horizontally, and then because of the boom potential, you have to launch it from a different place where you are building it. Meaning, if you are building it on a place, you should not fuel it where you are building it. So building has to be different, and launch building has to be different. So that creates a problem. On top of that, land you have selected is not supported by nature, meaning it's a marshy land, meaning if you dig a trench, water will just fill it over. So flame trench cannot be built. So you have to build a slope. Basically, you literally have to create an incline. In that you will have your slope, so to say. So fundamentally, these are the problem, and computers haven't been invented yet, as in like proper computer that you and I take for granted. 1960s, so they are not ready yet, let's be real. And then nobody has prior experience, meaning if you come up with this requirement today, people will look into this and it's like, okay, this is what we can do. Yeah, imagine being the first one who have to do this. Yeah, that's a difficult thing. And NASA built 2 of these puppies, and they are still in use. They are good puppies. Now, what's the core design here? Here's the deal. Marillion Power Shovel Company took the task. Now, this is old America. In old America, there used to be lots of companies. There were like a lot of systems. Right now, what we have is just like economic change happened, too much outsourcing to China happened, and now every company just basically became a brand and that has been bought by few centralized brands. Back then, that was not the case. So you could literally had this company is master of making mining equipment. This company is master of making buttons. I'm not even joking. There were like multiple companies that were just like such a niche thing. Like America did not reach a point where it's like, oh, they never had manufacturing. They lost their manufacturing capability. So back in that day, it was easy. They were just like, right, pick up the phone, find a good company. By the way, there were many companies that were expert in this thing. So they took this shovel company. The idea was, at that time, that was the world's largest shovel company. So they took the task. And be mindful, it was supported by everyone else because, again, national directive, go YOLO on it. So America built this, and it was $14 million. Now, of course, inflation. So that translates to $143 million. That was a very efficient, cost-efficient NASA. To give you a context, this puppy that was built 50 years ago, still working, $143 million. A launch tower they need for SLS Block 2, that tower supposed to be built for $200,000. Cool, awesome, decent enough. Yeah, that took $1.2 billion and not a single piece of metal has been welded or built. Nobody knows where the money went, and nobody has idea why a company that has never built a tower-like structure got a contract for building a tower. This is not said by me, this is from the government inspector office. It's like, what the hell is this? That's why Jared Isaacman cancelled the Block 2 system. The tower alone is not done. So that NASA is like, whoa, bro, you need something, we're going to build it. We're going to build 2 of this and you're going to use it forever. So that is it. How do you drive this puppy? Well, this is old school. So it's ahead of their time, which we call hybrid system. So you have diesel creates electricity does most of your work. And then you have hydraulic does most of the leveling. Because again, that's the whole thing. The inclines are 5 degrees. You cannot have a rocket that goes like this. These rockets are tall. And be mindful, Space Shuttle is very tiny in height wise. It's a fat boy. But Saturn V was tall. So going 5 degrees. So to make sure that does not happen, the level lifts it up. It can go like 4 feet down on one end and 4 feet up on the other. Like it has wiggle room. So, and again, the hydraulic has to have that much travel, so it can crawl below the vehicle assembly building, go there below this stack that you are saying, basically this platform, the rocket, go below it, lift it up, move it, still have enough travel in the hydraulic cylinder so you can climb the incline, go on the launch pad, drop it, pull back out. So all of that does require a lot of hydraulic power, like serious amount of hydraulic power. And the core locomotion of that leveling system, and not to mention steering, is also done by hydraulic system. And the platform remains level throughout it. And again, you are talking about something that is tall, and even the tip does not move. Like people have measured it, like this is stable puppy. Now you're like, how the heck they knew this is level? Yeah, they used mercury. Basically they had pipes that had mercury and that was leveling it. Because again, water, boiling, temperature, air trap, mercury solved all that issue. So they had mercury tube going from one corner to other corner, another corner to other corner, and that's how you are figuring out the level. It's like, okay, okay, hydraulic was doing it. Now again, this was another reason why these things is slow. Because again, hydraulics are not electromagnetic. They cannot go ta-ta-ta-ta-ta. They're not designed for rapid switching. So it's like easy. You have to ease into it. And not to mention, even if you could have a system that can go rapid, you don't want to shake the goddamn rocket. Not to mention the solid booster can go boom if you go. So fundamentally, everything of this was built like a tank, overbuilt to hell, and still survived. So that's the core functionality. Like it's a platform that's supposed to have vertical travel, compensation, and hydraulic steering with lot of beasts. And this whole structure that you see, it's actually just generators, 4 to 5 generators and some electronics. Be mindful, this was built before electronics. So if you see modern system, they have engineering room. Yeah, that was very analog back in that day. Computers weren't invented. So how do you power this puppy? Well, it itself is 2,720 tons. Yeah. And for SLS puppy, again, this was upgraded for SLS Block 2, which I don't think is ever going to be built. But that's supposed to be able to max loading 8,200 ton. Damn tonnage. So to understand that, if you are talking about something this heavy, it's going to drink fuel. Yeah, its fuel tank is 19,000 liters. Like it's at this point, it's better to talk in tons. This puppy has 16 tons of diesel. Tons. So main behemoth that drives this is Alco locomotive engine. Again, I'm not sure even that company exists anymore or not, or like bought and sold or whatever have you. So 16 V engine that generates the DC dynamo. Now be mindful, this is long ago. They still have DC generator. They still have DC traction motor, the actual traction motor that is spinning. And you see that disc and that disc brake. Yeah, those are traction motor. Yes, they are DC. Yes, they have brush. Yes, the alternator is also DC. So that's why dynamo. Why? You have to understand, this is 1960s technology. They did not figure out diodes yet. So, and not to mention, while we knew how to make what you call a AC generator, that was easy. There, you can just have slip ring, not split ring. DCs require split ring. Slip ring is very easy to manufacture. It was super easy to make an AC generator that just works. That was easy peasy. The motors, AC motors, were not sorted yet. While you could have induction motor, they did not have the torque. They did not have the torque. The motors that they are using are type of shunt motors, we call them. Yeah, these behemoths can have so much torque. Like there was an era like early 2000 to 2010 era where there were a lot of people who were like, using electrification on their vehicle using lead acid battery and traction motors from trains. Yeah, these things have so much torque, steel buckles under it, meaning this can just yoink your steel. Like this has more than enough torque. That's the benefit of having brush. Like it's a very recent thing. The dynamo to alternator jump happened the moment humanity figured out silicon controlled bridge rectifiers. The full bridge rectifier, the moment we had that, we did it, the end. But motors only changed recently, as in locomotives. I'm pretty sure the first one is after 2000, even though this technology, as in like have a generator driving a main engine, then driving the electrical systems, yeah, that's ancient, like 100 years old. So they have the same system. It still has DC. They thought of upgrading it. They did the full teardown of the locomotive engine, as in like the prime mover. Outcome was it's barely driven. Yes, it has driven thousands of kilometers, but the locomotive engine was designed for 10 years of continuous use. From engine's point of view, bro, it's like nothing. And not to mention, it's babied. Everything is babied about it. It's not getting exposed to the environment. To give you a context how babied these things are, when they have to go into the building and they have to remain in there for quite some time, there is an electrical ponytail. They basically plug it, what we call shore power, to make sure the temperature inside is maintained so it does not have to do cold start. Of course, it's not gonna have any issue. Oh, and not to mention this whole area, because they have to have people inside a locomotive engine, as in like close proximity, there's giant blowers blowing continuously inside it so people do not get cooked here. So that's the main generator, megawatt class. And then you have 16 of these motors in basically each bogie has 2 tracks. Each track have two motors. Most crane and bulldozer you see generally have only two motors, like on the back. This puppy has four, two on the front, two on the back, and then you have all fours. So 16, each one of them is like 300 kilowatt, basically almost 400 horsepower. Strong puppies. And again, why the motor is outside? So it can be serviced effectively. They thought of it basically. How the heck you gonna service it? So everything thought of. And recently they upgraded the auxiliary generator. That's the prime mover. They did not touch it. They're like, yeah, we need DC. Nobody makes DC. And again, if we try to make a DC, AC to DC now, people will try to have active bridge rectifier and this and all that. Of course, it can be done. And I'm reasonably sure it just won't be as robust nor as cheap. So they're like, just let it be. But auxiliary generator, because they do have blowers, electronics and all that jazz, hydraulic systems, they do require AC. So they're like, they used to have 750 kilowatt generator each. Now they have 1.5 megawatt generator each. So this puppy has almost 3 megawatt of aux power. Now, why do they need it? You will hear that they had to do that upgrade for load carrying, but it's like, bro, traction motor is the same. Why do you need that? It's for hydraulic. So hydraulic can compensate for SLS block 2 heavyweight flexing. It's like, whoa, 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 whoa. It needs that. Oh, steering is also hydraulically done. So it's very slow. It can spin in split because again, the electric motors are there. It has the programming where it's like spin and make a donut in one place. Behemoth, like this is a beauty. This is what America used to be like. You know, we built a thing and it will outlast Soviet Union. Now, how do you dance this puppy? Well, this needs whole team. Let that be fair. It's not like, okay, there is a driver that's gonna drive it, and yes, that's the first lady that got the certification to drive it. It takes a whole team. And the whole point is, take the rocket from the launch pad to vehicle assembly building. If you have to detank it or do something like that, detank as in like detank in the launch pad, and then of course you have to, SLS did a lot of that. I'm like pretty sure they are happy that they have a crawler that is so trustworthy, because SLS is not. So they have to do that. And the whole performance envelope of the system was designed. So if they get a hurricane warning, that generally should happen before 24 hours, they should be able to do that without any issue. These things, if they are following every procedure, there is no urgency, there is no rush, it will take 18 hours to go from vehicle assembly building to launch pad. If they are rushing it, they are moving ass, at that point in time, they can do that in 12 hours. They did do that with one Saturn V just to prove that it can be done, the procedure is done. Because when Apollo was at peak, they had 3 Saturn Vs in vehicle assembly building at one time. So the whole thing is, this is powerful things. Everybody who's in the team is trained for that hurricane scenario. Meaning, imagine SLS is there, they get a hurricane warning, yo, move. Now again, that was more of a 60s problem. Now we have enough satellites, we're gonna get a week early warning. So now it's not an issue, but again, it could happen, and the whole system was designed for that. They're like, can't you have the tower that can handle it? Tower can easily handle it. That's why they have that giant lightning arresters. Tower can tank it. It's just that you have a fuel tank. And if you are detanking it, and any minor debris can push, kaboom. So that's why that procedure is still maintained. And the road is covered by a special type of rock. This is what we call river rocks. And these rocks are specifically chosen, say they minimize static current buildup. When they get crushed, they have a certain properties that absorb static current. So, because be mindful, when you're seeing Saturn V and I'm saying it's does not have fuel, that is half true. It does not have the main propellant. It does have boatload of salt boosters, oleage motors, meaning when you are going in space, how the heck you make sure the staging happens properly? So you had small boosters that were pull the backstage back, small boosters that are push the front stage back, and then there's a and then the main generator is tight, ignite, so to say. So for that reason, imagine you are taking it there, static builds up, kaboom. So to make sure this rock element was chosen specifically, and to make sure that this does not become an issue, because again, you are talking about something so behemoth, it will crush all the rocks, and that's why these things keeps requiring washing. The moment it moves even more, it's like crushes everything into dust. So to make sure that dust is low, because again, the blowers that are filling the air inside will get covered up. So there is always a water truck, always, it has to be there. It keeps the dust low and makes sure the crawler does not inhale the dust. And there are two caps, because fundamentally, while it can turn, that was illogical, especially in the mount. Mount was not big enough where you can like go and then pull back and something. So they are like, okay, how do you reverse this puppy? Like a locomotive, you have caps on both ends. Although American locomotives don't have that. because they're like, we are we are never happy with one locomotive, we have two, so we have butt to butt in locomotives. So it's like, okay, technically you have cab on both sides. This has original design, cab on both sides. So that's the dance of it. It takes a whole team, minimum of 50 people. Like they're never gonna do it with if they have less than 10 people. Everything is checked. And be mindful, the primary upgrade was bearing was the weak link, and not a weak link. It was designed for space shuttle or Saturn V. SLS is way too heavy. And again, the core booster is solid booster. It's fully fueled, and not to mention now it has extra segment. Not to mention it has more engines. Instead of 3 engines, move 4 engines. The diameter is bigger, as in like the length is longer. So they're like, okay, how do we fix it? The structure is strong. It's just that structure compiles to a tapered roller bearing. The rollers are like this. So they're like, yeah, that is the weak link. So they throw it away. Now we have sleeve bearing, which is pressurized oil. That was another reason why they had to upgrade the generator. They need that pressurized oil to make sure that sleeve bearings are like, I got this. If their calculations are correct, which given the fact that SLS has not went to boom, it is functional. Now, what can we expect in the future? Well, you have to understand the market has changed. Back in the first space race, it was America versus Soviet Union, but there was a different era there. The era was country versus country. It's like mine's bigger than yours. So it was country versus country. Now, which we have the same thing as in like China versus USA. However, now it's like America has reached a mature point where it's like, hey, it's not that mine is bigger. I have proved mine is bigger. It's just that my kids have bigger. So private players, they have to play. So privatize the system, meaning now they can't afford something crawler like that. Like, yeah, that is way too behemoth, way too expensive, way too what you call tailor-made. Like, it's great. It did its job. It is more than like, it's one of those things where it's like, it should serve us for Apollo. It's like, bro, it's still serving. And basically the crawler hardware, the metal, I have no idea how the heck the metal is so overbuilt that it has not fatigued yet. Like they are not even worried about the metal. It's like, bro, it was so overbuilt. We good. So that is no longer economically viable and nimble enough. It's like too slow, too cumbersome, takes too much. So what is the solution? Solution is self-propelled modular transport. Did we not have that back then? Not really. That was just ideas were just coming into the market and was designed for transformers. And again, computers were not ready, so you could not have hundreds of wheels balancing each other. Nowadays, we take it for granted. It's like, bro, pick up a phone. Again, even in India, you can pick up a phone. There are more than enough companies that's like, yeah, we have a self-propelled modular transporter. How many you need? Like, oh, you need like, let's say 400 tons, we have this. You have 2000 ton, we have this. And that's the whole point of the modular part. You never buy basically different size. You just buy one unit and you add unit based on your requirement. So that problem has been sorted. And most rockets are going horizontal. We are not going we are not doing that. That's stupid. So we are like doing. Now, to be fair, Soviet Union's approach was that they're gonna have rocket like this and then go like this. So it's like that was pushing it, and given the fact that rocket went boom way too many times, I would say that was pushing it. So the idea is going horizontal. Basically Falcon 9 horizontal, then it goes yoink. Basically Falcon Heavy, yoink. Blue Origin, yoink. So India's next generations of rocket, next generation launch vehicle, they will also be yoink. So more and more are moving into horizontal system. However, you might be like, Starship is not. Yes, because it does not have a what we call rollout. What it's supposed to do is take the booster, take it to the launch pad. Launch pad has the grabber arm. It's going to grab it, put it on launch mount. Then another transporter will come there. They're going to yoink the basically Starship, put it on top. So there is no vehicle assembly building. There is no place where they can safely build it. So if they have to build it, they have to build it on the launch pad itself. These things are generally designed in such a way that if a fully fueled rocket goes kaboom, it should not damage the building. And again, the vehicle assembly building was overbuilt because it's supposed to tank a hurricane full force. It's like hurricane is going YOLO and the building should be like, brah, please. Brah, please. Oh, it's a woman's name. Yeah, bitch, please. So that was the whole idea of that. So even in the basically New Glen's scenario, it's 9 kilometers. So it's more than enough that rocket goes kaboom, the system would be like, bro, we're fine. Minor paint damage, that's also if. So they're doing that. Basically, take it horizontal with rails and then move it. and we have modular transporter that can easily tank that 5-degree slope. We can even tackle like 7 or 8 degree nowadays. That's not an issue. Rails are still good for government, meaning ISRO does have the luxury of solid ground, like tanking ground. Like this ground can handle it. And if you look into Russian system, they also use rail because the soil is strong enough where it can tank it. So for government system, rails are good. For all private players, sooner or later they have to go into this multiple wheel systems, self-propelled modular transport. So in future, we are not gonna see anything like crawler unless there is some very niche use case. I don't think that will happen. But again, I'm pretty sure crawler is like one of its kind, and they're gonna keep using it because there is nothing else that can do SLS. And unless they retire SLS, there will be a need for it. So a second one has not got any love because they originally gave it for a private company. They did not use it. So let's see what happens. So this was my presentation on basically how the heck you move a rocket after building it. So hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you enjoyed it, I would say click the like button. If you didn't like it, didn't enjoy it, I urge you to press dislike button, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.